Okay, now we'll take a look at finding a confidence interval for a mean. We're continuing with the kitten weights example from our hypothesis test. So we have already established that there is statistically significant evidence that the mean kitten weight from a FeLV positive mother is lower than the mean kitten weight across the board. And now we want to estimate the mean kitten weight from a FeLV positive mother. We're using this same standard error formula, S over square root of n for one mean. And to find a confidence interval, we're following the same general model that we've followed in the past, which is sample statistic. In this case, x bar, plus or minus a margin of error. So very similar to how we found our margin of error previously. Instead of a z star critical value, we now have a t star critical value. But it's following the same idea, t star critical value times standard error. And our standard error is given by the formula S over square root of n. T star is a critical value for the t n minus 1 density curve, meaning the t distribution with n minus 1 degrees of freedom. And it's the critical value that we will see how to look up in this table. So first of all, calculating the standard error, we have that the standard error, SE, is equal to S over square root of n. And if we recall, our sample standard deviation for this data is 9.656. And our n is 10. We had 10 kitten weights. So this is 9.656 divided by the square root of 10. Which gets us 3.053. Now we want to find our t star critical value for a 95% confidence interval. Again, we have 9 degrees of freedom because that's our n minus 1. And we also want a 95% confidence interval, so I'm going to look only at the column corresponding to 95% here, which means I'm going to focus on just this column for 95%, and I'm going to focus on just this row for 9 degrees of freedom. And I can see that where they intersect there, I get just one value. That is my t star critical value. So t star is this 2.262. Putting these pieces of information together, we can now find a 95% confidence interval. The margin of error is given by the t star critical value times the standard error. So that's going to be 2.262 times our standard error of, I think, 3.053. Yes. Bring in a calculator for that. 2.262 times 3.053 gets me 6.906, if I round that off. Usually when I first write down my margin of error, I take it out a little bit farther than I'm going to ultimately want it, and then decide in the next step how many digits to keep. My mean, x bar, is 92.5. So when I go to my confidence interval, x bar plus or minus the margin of error, it seems reasonable in this case to take them both to the same number of digits. If my margin of error were very small, I might take it one decimal place further, but given that it's 6.9 on a scale of a mean of about 92.5, it seems like one decimal place is plenty for this. So I'm going to subtract to get my lower bound and add to get my upper bound. 92.5 minus 6.9 gets me the lower bound of 85.6. And 92.5 plus 6.9 gets me my upper bound of 99.4. So this is my 95% confidence interval for the mean kitten weight from a FeLV positive mother. Now I'm going to interpret that confidence interval. These kitten weights are in grams, so I do need to think about units for this. And if each weight is in grams, then the mean weight is also in grams. But what we're saying is that for all kittens born of a FeLV positive mother, because we do want to extend to the population for a confidence interval, we believe that that mean weight is between these two values measured in grams. So my interpretation is with 95% confidence, the mean weight of all kittens born from a FeLV positive mother is between 85.6 and 99.4 grams. Make sure that your statement has the word mean. And make sure that we are talking about the population, that it's clear from your sentence that it is a statement about the population, not about your sample. And also make sure to include those units. It's not a statement without units. The only situation in which we don't generally include units is if our confidence interval is for a correlation, because correlation is unitless. But anytime the numbers can be described by a unit, we need to indicate what that unit is.